Okay, now let's see how can we use the comprehension to create the same thing. So I'm just going to call this cars comp for comprehension. Okay, so this is the list. This is the set I'm going to build using the comprehension. Or maybe for the comparison, I'm going to use a similar name, but with extension comp. Okay, so this is the end result, the set that ends, the results from that comprehension. Okay, now I want to build a set. When we wanted to build a list, we said that everything should go into square brackets, right? Now here, this is not going to be empty, so I can use the square brackets, the curly brackets, to say that I want to create a set. Now remember the comprehension. So here we need an expression. Okay, I'm going to change that. So expression that represents the equation, and then the for loop that we use to iterate over the sequence that we want to use to build the comprehension. And then we can add a condition if we want to, right? So these are the three main components, right? So the expression here I am looping over as characters in a string, right? So this is my sequence here, right? So I want to say that add to this set something like a character, okay? Okay, I want to use a different name so that you can see the error. All right. So let's say C. Now, at this moment, there is no such thing as C. There's a variable that is not defined. Okay, but when I say like this, I say every element in this set will take a value that was stored in this variable. Now, where the values stored in this variable come from? They come from this loop. So for C in my sequence or my iterable that I want to use to build the set, which is at this moment is a text. So this variable that is a string. All right, so do we understand what does that mean? So I'm saying that this part says that every element in this set will take its value from the variable C. Now the value of the variable C will take a different value in every iteration in this loop. So at this moment, I'm saying that just give me the characters, all the characters in the text, and put them into a set. But there is something in the nature of the set that it eliminates duplication, right? So let's start that. We're not going to add the condition now. Let me just print it first and see what the result of this comprehension. All right, so this is the first one here, and this is the second one, which is just every character in the text, but with eliminating duplication. So that's the nature of the set itself. We didn't have to put any code in order to eliminate duplication. All right? Yes. Which loop are you talking about this? So the loop itself loops on every single character in the text, right? We are trying to do the same thing that we did in this loop using the comprehension syntax. So at this moment, I didn't add the condition yet. Yes. So this loop, naturally, if I put it in the actual for loop outside of the comprehension, what does it do? The variable C will have the would point to one character of the text at a time, right? Okay, now I put this loop inside the comprehension. I'm saying that give me that character that you iterate over and add it to the set. Now I don't want all of them. I want to have some condition to filter them out. So just like we added the condition, the syntax in the long form of the loop would go like this. The syntax for the comprehension would go after the loop. I say if C not equal space. All right. And so now if I run this, then it should give me the exact same result. Okay. Now this doesn't have to be just a simple variable. It can be any expression that apply on this variable. So this is the minimum. Okay. All right, now let's talk about dictionaries. Obviously, we can loop over the elements in the set using a for loop. Now, the second type that we need to talk about today is the mapping type. Though there is a category called mapping, but it's only one type underneath it, which is a dictionary. Yes.
Go back.
Yeah.
Is it the same order all of them?
There is no meaning of order.
The expression all uppercase in the composition. Make the expression all everything uppercase with the order of all
There is no meaning of order at all. You mean you want to turn this to upper?
if it is upper, is it going to be the same? Like, be different.
It would be different hash because a different value, but it doesn't mean that it's the order. So don't use the word order with a set altogether. Okay. It would be a different hash, that's for sure, because that's a different value. It has a different Unicode. You can even try it out here. So let's say hash lowercase a. Okay, now hash uppercase a. Not the same. Okay, now let's see. The dictionary is a mapping type. So what does it mean? Map. So in Java there is a data type called, or there's a class called hash table. That is what is equivalent to the hash to the dictionary here. Okay, so the dictionary is just a key value pairs. Okay, the elements of the dictionary, each of them are key value pairs, and the key and value are separated with a colon. The elements themselves are separated with commas. So you see here, this is the key and this is the value. And then comma means that this is the second element in the dictionary and this is the third element. Okay. Now we are used to use the numbers as keys. That's very easy, right? But in the dictionary here, you can use anything as key as long as it is hashable. So the key is pretty much used in order to access the value. So it needs to be indexed, even though it's not numerical. Okay, so we can use string. The string is hashable, so there's no problem with that. Can we use a list? We cannot use a list because the list is mutable, so it's not hashable. We cannot use it as a key. We can use it as a value. But if we want to use something equivalent as a key, we need to turn it into a tuple. Okay, we can use a set as a key. Can we use a set as a key? No, we can't. If we need to, then we turn it into a frozen set, and then we put it in a different. Okay. And then same with the list, we have to turn it into a tuple. So the key must be hashable, the value doesn't have to be hashable. Now here's the thing, we use the key in order to access the value as an index, right? So we are very, it is very convenient for us, or very common that we see a number used as an index. But now with the hashing, we can use anything as an index as long as it is hashable. So you see here, because we put the tuple as the key, we can use it as the index to access the value corresponding to it. Okay. Now we can do that for reading and for writing. So when we don't use the equal sign, we are reading, so returns or this expression evaluates to that value corresponding to the key. When we use the assignment or the equal sign, then we are writing the value that is corresponding to that key. Okay. Now, if that key didn't exist beforehand in the dictionary, what happens? It doesn't give you an error. It adds it to the dictionary and associate the value to it. Okay. All right. Now, as you can see, the brackets that surround the dictionary also are curly brackets. Okay, but it is able to distinguish between the set and the dictionary from the values inside. So if there are key value pairs, it's a dictionary. If it's just a single not key value pairs, then it's a set. All right. But what if there's no values inside? If just the curly bracket is empty, then it is a dictionary, not a set. Okay. Okay. And similarly, just like we were able to use comprehension for a set, we can use comprehension for the dictionary. All right, using again the curly brackets, but the expression itself will distinguish between whether it's a set or not. So the comprehension to create a dictionary in the expression has to have a colon, so you are creating key value pairs. Okay, and again, you can also create it using a loop like this. So let's try out this. If we are trying to create a dictionary that is maps the value to its doubled value. Okay, so I'm not sure if we have enough time for that. Okay, well, perhaps we should stop here and start with the hands-on.